Understanding aircraft engines, the heart of modern aviation technology. Whenever we take to the skies, we are aware of the aircraft we are aboard, whether it be Airbus, Boeing, ATR, Embraer, or similar. However, have we considered the immense power and the engine responsible for ensuring our safe journey? In this video, we will examine the incredible strength of the engine that ensures our safe travels. Aircraft engines serve as the vital core of aviation, delivering the essential thrust required to navigate aircraft through the air. These intricate devices have undergone remarkable advancements since the Wright brothers achieved their inaugural powered flight in 1903, enhancing their efficiency, power, and reliability over the years. In the present day, aircraft engines are indispensable not just for flight performance but also for ensuring safety, optimizing fuel economy, and minimizing environmental effects. Different kinds of engines are utilized in various aircraft based on their size, the distance they need to travel, and the weight of the aircraft. There are several types of engines used in aviation, each suited to different aircraft and mission requirements. Piston engines, reciprocating engines, used in small general aviation aircraft. How it works? Similar to car engines, they use cylinders and pistons to convert fuel into mechanical energy, which turns a propeller. Advantages: simple, cost-effective, and efficient at lower altitudes. Limitations: limited power output and less efficient at high altitudes or speeds. Manufactured by Lycoming Engines, USA, a subsidiary of Textron. Continental Aerospace Technologies, USA. Rotax, Austria. UL Power Aero Engines, Belgium. Jabiru Aircraft Engines, Australia. SMA Engines, France, now under Safran. HKS, Japan. Turboprop engines, used in regional and small commuter aircraft. How it works? A gas turbine engine drives a propeller. Combines features of piston and jet engines. Advantages: fuel efficient at medium speeds and altitudes. Limitations: slower than pure jets at high altitudes. Manufactured by Pratt & Whitney Canada, GE Aerospace, General Electric, Rolls-Royce, Honeywell Aerospace. Motor Sich, Ukraine. Ivchenko Progress, Ukraine. Klimov, Russia. Turbo Mika Safran helicopter engines. Turbojet engines, used in early jet airliners and military jets. How it works? Compresses air, mixes it with fuel, and ignites the mixture. High-speed exhaust generates thrust. Advantages: high speed and power. Limitations: noisy, less efficient at lower speeds. General Electric, GE Aviation, USA. Rolls-Royce, United Kingdom. Snecma, Safran Aircraft Engines, France. Klimov, Russia. Saturn, NPO Saturn, now part of United Engine Corporation, Russia. Ivchenko Progress Motor Sich, Ukraine. Williams International, USA. Turbo Union Limited, multinational, UK, Germany, Italy. Turbofan engines, used in most modern commercial airliners. How it works? A fan at the front pushes air through the engine and around it. Combines bypass air with jet thrust. Advantages: quieter, more fuel efficient than turbojets. Types: high bypass, airliners, and low bypass, fighters. General Electric, GE Aerospace, Rolls-Royce, Pratt & Whitney, Raytheon Technologies, CFM International, JV, GE Aviation and Safran Aircraft Engines. Safran Aircraft Engines. Aviadvigatel, United Engine Corporation, IHI Corporation. LMC, Liming Aircraft Engine Company, China. Turboshaft engines, used in helicopters. How it works? Similar to a turboprop, but instead of turning a propeller, it powers a rotor. Advantages: lightweight, reliable, and efficient for vertical flight. Safran helicopter engines, formerly Turbo Mika, Pratt & Whitney Canada, P&WC, General Electric Aerospace, GE, USA, Rolls-Royce, United Kingdom, Klimov, United Engine Corporation, Russia, Motor Sich, Ukraine, HAL India, IHI Corporation, Japan, electric and hybrid engines, emerging, used in experimental and light aircraft. How it works. Use electric motors powered by batteries or hybrid systems combining fuel and electric power. Advantages: lower emissions, quieter, potentially lower operating costs. Challenges: battery weight, limited range, and certification hurdles. The predominant engines utilized in commercial aircraft today are high bypass turbofan engines. These engines are selected for their outstanding fuel efficiency, reduced noise levels, and significant thrust output, which makes them perfect for long-distance and high-capacity flights. Listed below are some of the most commonly used commercial jet engines as of the mid-2020s. So let's get to know more about it. Most widely used jet engine in Boeing 737NG and A320ceo is CFM56 made by CFM International. New-gen, fuel-efficient engines used in A320neo and 737 MAX are LEAP 1A and be made by CFM International. Geared turbofan tech engines PW1000G made by Pratt & Whitney Powers, A320neo and Embraer E2. Boeing 777 comes with GE90 from GE Aviation for high thrust, long haul. Advanced, triple-spool Trent series engines from Rolls-Royce Powers A330, A350 and 787. GP7200 large aircraft engine from Engine Alliance provides the power for Airbus A380. We believe that you now have an understanding of the engine's power, which enables us to navigate the universe swiftly and safely. The next time you take a flight, you may recognize the engine that propels you, depending on the type of aircraft you are on. Brought to you by Untold Facts from Maroli Edutech. Thanks for viewing this presentation. Please share and subscribe to our channel. Stay tuned for more informative videos.